Welcome, my name is Fabian and I'm going to talk about how to build availability requirements into the logical design. When we create a logical design, availability is a crucial part of it. We need to integrate availability right from the beginning to meet the business needs. So we have identified certain requirements in the conceptual phase, and now we need to identify which of those requirements are having an impact on availability. So let's have a look. For example, all service, network, and storage components, they must be designed in a way that they can tolerate the failure of one component. So we have a classical N+1, N+2, N+M design that is built in a way that those components can fail without having any impact. Solutions like a network adapter, like a switch, like a server should not interrupt the overall service of our environment. Okay? So we need to size the environment in a way that we fulfill this requirement. And that is really, really important for all components within our infrastructure, storage, network, compute. Very, very important right here. The other thing, and to be honest, the key concept here for availability is always avoid the single point of failure. We need to avoid the single point of failure, and not just for failure scenarios, but also for maintenance scenarios. So if we want or if we need to patch our Windows operating system, we don't want to disconnect all users in our environment. We don't want to have a heavy impact on our virtual desktop infrastructure solution. So what can we do here? When we want to be still operatable during maintenance windows, we can do several options. One of that is, for sure, we install our connection service in a replica mode. So we have multiple connection servers where we can do kind of a failover, can make sure that no session is connected over a connection server before we do the maintenance mode. And at the same time, we can make sure that the connection of the end user to the virtual desktop is probably not tunneled over the connection server, which means we have a direct connection between the endpoint, so the location where the client is, and the virtual desktop in the data center. If we have a direct connection, we can lose the connection server without having any service interrupt. So the user is still able to interact with his virtual desktop. If we do an operating system maintenance, the user is still able to work during this scenario since we have a direct connection. For sure, that's a good example, that has an impact on security, on network design. So we need to figure out what is more important for our organization, security or availability. Since we talk about availability facts, we made the design decisions. We want to have, for internal users, a direct connection between the endpoint and the virtual desktop. What else can be a requirement? In case of a data center outage or any kind of data center maintenance test, we must be able, the solution must be able to still provide access to virtual desktop services, to virtual desktop functionality. So in case our data center in London fails, we must be able to still connect to our virtual desktops in New York, for example. And we can utilize a feature called the Cloud Pod feature to make sure that we have multiple pods integrated with each other and use the other pod as a failover pod in our environment. So when we talk about the components of Horizon and the availability options, we need to understand what limitations we have. We need to understand what characteristics is behind those components, also in the logical design phase. So the following components can be designed in a high available fashion: the connection server, the security server. But remember, the security server always has a one-to-one relationship from security server to a connection server. We can scale out, for availability reasons, the unified access gateway. We can scale out the identity manager, and we can scale out the app volumes manager to improve, to enhance the availability of our components. Important, all of those components require a third-party load balancer or an NSX-based load balancer in front of them. The load balancer is doing the health check and figures out if there is a failure of a certain component and does an automatic failover to the other redundant component. Important, all of those configuration items must be configured with session affinity. Okay, so if we configure the load balancer, it must have some sort of session affinity. There's one component where we cannot really create high availability, that is the Horizon View Composer. The Horizon View Composer is used in case we want to utilize linked clones. What is a linked clone? A linked clone is a virtual desktop that consists out of a kind of a master of a parent virtual machine, a virtual desktop, a parent virtual desktop, and every instance of this virtual desktop is just the delta between the instance itself and the parent virtual desktop, which means we are easily able to push out new updates to refresh those desktops to a clean state in a very centralized manner. The link clones always require for those operations to occur, rebalance, recompose, refresh, the so-called View Composer. And the View Composer is a single installed component that we cannot do or cannot install in a high available fashion, that also requires a SQL database in the backend. Important, we don't have this single point of failure constraint for instant clones. So instant clones are similar to linked clones, but they differ in a way that instant clones are kind of instantly created virtual machines, making a delta out of the memory, making a delta out of the disk, and creating virtual machines on the fly that are available in a running state. So we don't require for instant clones the View Composer. We just require the View Composer for our linked clones. And again, if we want to make them high available, we can place, or higher available, we can place those components on a cluster that utilizes vSphere high availability. So remember, vSphere high availability can be used always as an addition to existing application-based availability methods. So we place all of our connection servers on a high availability cluster. We make sure that they are separated from each other with anti-affinity rules, and therefore we increase the availability of our Horizon environment. When we talk about the cloud pod architecture, it's important to know that we can integrate multiple pods with each other. So what is a pod again? A pod consists of a management block and a minimum of one resource block, and is one Horizon instance. And this Horizon instance is kind of an endpoint for the user to connect to typically. So since we don't support any kind of multi-data center architectures or multi-site architectures within a Horizon pod, we need to do something if we want to integrate multiple pods from different physical location into one logical unit, and that's where we use the cloud pod architecture. So the cloud pod architecture simplifies the administration effort within our environment. Okay, so we can give the user a single dedicated entry point into the virtual desktop infrastructure, even though the physical characteristic is separating our pods in different locations. So we have a single URL for the end user. We can utilize it for active availability, disaster recovery scenarios, and we can support users that are coming from all parts of the world to redirect them properly to the correct pod of their environment. So how does it look like from a logical level? The end user is connecting to a global load balancer. And the global load balancer is connecting the end user to the closest pod of the end user. So in case a major outage occurs and the whole data center site fails, like here in London, we are able to discover that failure over the load balancer and make sure that the user is redirected to a virtual desktop in the New York location. So that's something we can do with the cloud pod architecture. The important thing is, for sure, we need to make sure, how do we create the availability? How do we synchronize the data? How can we replicate the data, the user data, from the London location to New York? But this is something we need to handle on a file share level in the end.